So for classroom example 7, this is another compound inequality. So negative 4 is less than or equal to 2x over 5 minus 1, which at the same time has to be less than 0. So let me go ahead and just rewrite that. Less than or equal to 2x over 5 minus 1 less than 0. A very common mistake is to not write the sign correctly, so be very careful to make sure if it has an equal sign or if it doesn't. All right, we want to get that x by itself, so the first thing I'm going to do is add 1 to left, middle, and right. Negative 3 is less than or equal to 2x over 5 is less than 1. Okay, let's multiply, let's clear the fraction first. I'm actually going to do this in 2 steps. I could multiply by 5 over 2, 5 over 2, 5 over 2, but let's kind of just multiply middle, left, and right by 5 to at least clear the fraction first. 5 times negative 3 is negative 15, less than or equal to 2x less than 5 times 1 is 5. All right, so now I don't have a fraction anymore. But I want to get x by itself, so I'm actually going to be introducing a fraction again. Negative 15 over 2, which is like negative 7.5. That's between negative 7 and negative 8. X is going to be greater than or equal to negative 15 over 2, but at the same time less than 5 over 2, which is 2.5. I'm doing this because we do need to know, since we're going to be doing a graph, where to put them on the graph. All right, so if here's 0, negative 1, 2, 3, 4, 5, 6, if here's negative 7 and here's negative 7.5, here is negative 15 over 2. And x is going to be greater than or equal to that. 1, 2, 3. Here's 2.5. 5 over 2 is between 2 and 3. But x has to be less than. There's no equal sign, so that's going to be a paren. So this is the graph of my solution. The lowest possible value, it can be greater than or equal to 15 over 2, less than but not equal to 5 over 2. And just to check, if what I've selected is true, 0 would be in my solution region. So I'm going to go back to my original inequality and plug in 0 everywhere I see an x. And hopefully I'll get a true statement. Well, anything multiplied by 0 is 0, so 0 in the numerator is going to be 0. So I have negative 4 is less than or equal to 0 minus 1, which is less than 0. So 0 minus 1 is negative 1. Is negative 4 less than or equal to negative 1? Yes, it is. Is negative 1 less than 0? Yes, it is. So it checks. So this is the correct interval notation of my solution. So now you're going to go and try for yourself practice 11. And for classroom example 8, now we're going to have to do some translation. We're going to have to create the inequality ourselves and solve it. So the number is going to be x. So twice a number, 2x. After we double it, decreased by 25. Decreased by 25 means subtract 25. Twice a number, decreased by 25, is less than or equal to, that's your less than or equal to sign, less than or equal to 101. Solve using the number line and give interval notation. So we've done our translation. Now we want to solve for x, get x by itself. So I'm going to add 25 to both sides. 2x is going to be less than or equal to 126. Divide both sides by 2. I do not change the sign because this was a positive number. So x can be less than, any number less than or equal to 63. So if here's my 0, here's 20, 40, 60, right here would be 63. You don't have to draw 63 little ticks. X is less than or equal to 63. And so interval notation, since that arrow is going on to infinity, we're going to have from negative infinity to 63, and since that was an equal sign, it can equal 63. Here is my interval notation. So what you're going to do is do practice number 12. But as a reminder, we learned how to write a linear inequality and how to graph on a number line and interval notation. So then we had some inequalities. Then we had compound inequalities where x was in the middle of an upper and a lower bound, and then a word problem, a translation problem.